Hello students, welcome back to our channel Abhyas IIT Prep. In this video, we are going to discuss about the 24th Jan morning shift paper. Let's get into the video. See this first question number 26 from section 1. What is the dimensional formula for magnetic induction, magnetic flux and magnetic permeability and self-inductance? So we know that one formula for a magnetic, for a magnetic induction, we know that formula force equal to QVB. So from this one, if you want to find dimensional formula for magnetic flux, magnetic induction, you can say this one, M L to the power 0, T to the power minus 2, A to the power minus 1. This is our dimensional formula for magnetic induction. What about magnetic flux? Magnetic flux can be written as phi equal to B dot A. So this is option B. So see here, flux can be written as dimensional formula for flux can be written as M L square T to the power minus 2 A to the power minus 1, which is option. So magnetic induction you are having option 3 and a magnetic flux you are having, what is this, option 4. Option 4. So next one, see here, one more is there, option C. What is this one? C is nothing but a magnetic permeability. So magnetic permeability mu can be written as ML T to the power minus 2 A to the power minus 2. That is the magnetic permeability dimensional formula. What is the option? Option 1 is the right answer. So from this one you will get option 4 is the right answer. So next question, see here. Question number 27. 3 charges they have given plus Q, 3 plus 3Q and minus 4Q are situated at, they have given some positions respectively in XY plane, the resultant dipole moment. What is the formula for dipole moment? So dipole moment can be written as charge into distance, whatever it may be, L or R, whatever it may be, it must be measured from the origin. So take the positions, XY plane, draw. So this is our XY plane, this is X and Y. So what is the position for plus 2Q? Minus 3A, X, Y, X, Y, XY. So minus 3A you will get here, minus 3A, that is nothing but plus 2Q. What about plus 3Q? It is at position 2A. 2A at plus 3Q charge. At position minus 2A, you are having minus 4 charge. So how to find this one? Resultant dipole moment is nothing but adding of individual dipole moments. So this can be P1, P2 and P3. So this is our net dipole moment is nothing but P1 plus P2 plus P3. So P can be written as, so see here, from this one, see here, minus 3A into plus 2Q, this is actually J cap, plus 2A into 3Q I cap, minus of minus plus 2A into 4Q I cap. So if you solve this one, you will get 2AQ is nothing but 7I cap minus 3J cap. This is our right answer. Option 3 is the right answer. I hope you are understanding. So next question, see here, question number 28. A cylindrical block of mass capital M, area of cross section A is floating in a liquid of density rho and with its axis vertical. When dispersed a little and released, the block starting oscillating. The time period of oscillation. What they are asking? So one cylindrical block is there, okay, which is in liquid. Take this one. This is our liquid. So take this height can be h. Take that height as h. So what we are doing, we are just pushing this cylindrical shape. So then it is making some oscillations. So at that oscillation, you have to find the time period. How to find this one? At equilibrium, we know this one. So downward, always gravitational force mg, upward Buoyancy force. So F can be written as so see here, pressure is nothing but force per area. So F can be written as so rho GH into area. So at equilibrium position, so mg equal to rho GH into A. So after pulling some distance x, if this came to some extended to some distance x, what will happen? Total distance can be written as h plus x. So it is moving downward, acceleration is downward. So from free body diagram, you can say this one, capital mg minus rho gh plus x into A is nothing but ma. This is our next equation. So see this one, mg minus rho gha minus rho ghx is nothing but ma. If you see this first equation, equation number 1, mg equal to rho gh. So this can be written as mg. So mg and mg can be cancelled. So from this one, see here, A equal to minus gh rho gh by m into x. This is our condition for oscillations. So acceleration can be written as A equal to minus omega square into x. So here, if you observe here, what is the time period formula? Time period can be written as t equal to 2 pi by omega. So from this one, 2 pi into here, see here, rho gh by capital M. So m by rho gh under root. This is our final answer. So what is the correct option? So kindly pause the video. Please let me know the correct option in comment section. So next one, see here, option 1 is the right answer. So next one, see here, question number 29. The density of water at 4 degrees centigrade and 20 degrees centigrade are 1000 kg per meter cube, and one more is there, one more density is there, 998 kg per meter cube respectively. The increase in internal energy of 4 kg water when it's heated from the 4 degree to 20 degree. What they are asking? They are asking internal energy. They are asking internal energy. How to find internal energy? Internal energy. What is the formula for internal energy? Delta U can be written as delta Q minus work done. What is the delta Q? First you have to find delta Q. How to find delta Q? So Q can be written as ms delta T ms delta T. What is the mass? That is nothing but 4 kg. What is specific heat? So per joule, we don't want to for kg, we want for joule. So 4200 into what is the change in temperature? 16 degrees. What is the change in temperature? 16 degrees. From this one you can write it as 268,800 joules. This is the our heat. This is our heat. So next one you have to find a work done. Work done can be written as a P into delta V. P into delta V. So delta V can be written as, so just wait, what is this one? Mass by density is nothing but volume. Mass by density is nothing but volume. So see here, pressure they have given already. Pressure is nothing but 10 to the power 5 pascals. I am not writing pascal here. So see. Okay. Now we have to find the delta U. So see here, M is common. That's why I am taking outside. 4 1 by rho final minus rho initial. What is final? 998 minus 1 by 1000. So if you solve this one, if you solve this W work done, you will get the 0.8 joule. So this is our work done. If you substitute in this formula, you will get the answer 4th. You will get the answer as 4. 268,799.2. That is your answer. So next question, see here. Two resistors of 100 ohm each are connected in series with a 9 volt battery. A voltmeter of a 400 ohm resistor is connected to measure the voltage drop across the one of the resistor. The voltmeter reading. What they are asking? They are asking for voltmeter reading. What is the condition here? We are having two resistors which are connected in series. Those are 100 ohm resistors. So kindly observe here. So which is connected to 9 volts battery, and one of the 100 ohm resistor is connected with a voltmeter is having a 400 ohm resistance. 400 ohm resistance. So you have to find the resistance. So you have to find the voltage reading of the voltmeter. So see here, 9 volts. This is 9 volts. So first we have to find R equivalent. From that one you can find current. After that one we have to find voltmeter reading. So R equivalent can be written as, what is this one? 100 plus, I am writing directly 100 plus 400 into 100 by 500. So this is the resistance for the voltmeter as well as 100 ohm resistor. So see here, 100 is cancelled. This is our 80. Remember this resistance here. We are getting a resistance of voltmeter with respect to voltmeter 80 ohm. So this is 80. This is 100. 180. So if you want to find I equal to V by R, that is 180 1 by 20 amperes. This is our current. So you have to find the voltmeter reading. So voltmeter reading can be written as I into R. What is that R? 8 ohm. So 1 by 20 into 80 you will get 4. So option 3 is the right answer. So next question, see here, question number 31. The exist surface of a prism with a refractive index n is coated with a material having a refractive index n by 2. When the prism is set for the minimum angle of deviation, that is nothing but minimum deviation, it is exactly meet the condition of the critical angle. Then what is the prism angle? So see here, what they are asking, the prism is having a refractive index. This is refractive index n, and one more face is there that is having a refractive index n by 2. We know that one minimum deviation formula. This is our R. This is our R. What they are asking? They are asking for the angle of the prism. Okay, see here. For total internal reflection. For total internal reflection, what is the condition here? So, sin IC can be written as mu2 by mu1, that is nothing but n by 2 by n, that is half. So we know that one condition for R is a by 2. So from this one, write it as sin a by 2 is nothing but what is this? Sin 30 degrees. So sin 30 degrees. So if we compare these two, you will get a 2 into 30, that is nothing but 60 degrees. That is our angle prism. Prism of angle is 60. Question number 32. See here, two electrons are moving in orbits of a hydrogen-like atom with the speeds. They have given two speeds, meter per second respectively. If the radii of these orbits are nearly same, this is very, very important. So R1 is equal to R2. Then the possible order of energy states are. So we know that one, a velocity of electron is revolving around a orbit is nothing but z by n. So for radius is nothing but n square by z. From equation 1 and 2, you can simply write R equal to n by v. From 1 and 2, you can simply write R equal to n by v. So in the question, R1 equal to R2. So n1 by v1 equal to n2 by v2. So what you have to find? You have to find the possible order of states, energy states. So see here, from this one, n1 by n2 equal to v1 by v2. What is v1? 3 into 10 to the power 5 meter per second and 2.5 into 10 to the power 5 meter per second. If you solve this, so take this one. So 6 by 5. So these are our order. So 6 and 5 are the orders of the energy states. So next question, see here, question number 33. In a microscope of a tube length 10 centimeter, two convex lenses are arranged with focal length of 2 centimeter and 5 centimeter. The total magnification is obtained with his system of normal adjustment is, they have given magnification value. What is the value of k? So magnification is nothing but 5 to the power k. You have to find the k value. Simple formula. Magnification, everyone know that formula. dl by focus of objective length, focus of the eyepiece lens. Simple. What is the d value? You have to remember 25 centimeter. So see here, 25 into what is the length? Length is 10 centimeters. 10 centimeters by 2 into 5. So cancelled. 2 to the 5 to the power square, that is nothing but k value. K is nothing but 2. So see here, option 1 is the right answer. So next question, see here, question number 34. What they are asking? They have given LCR circuit. Very easy question, but you have to remember one beautiful formula, single formula only. So for the series LCR circuit connected with 220 volts 5H AC circuit, AC source as shown in figure, the power factor, you have to find power factor alpha by 10, then what is the value of alpha? They are asking for a number of times, they are asking for some constant value. They have given already answer, but they are asking for one constant value, so alpha, n or m. So see here, what is the power factor? So power factor can be written as R by Z. R by Z. What is the Z? Z is nothing but impedance. What is the impedance in LCR circuit? So Z can be written as under root R square plus XL minus XC whole to the power 2. So they have given all the values in diagram. You have to just substitute and simplify. So R square, that is nothing but R is nothing but 60 XC XL. Okay. R square 60 3600 80. You will get 80. So 6400 and a root. So from this one you are having 100. So impedance is nothing but so power factor is nothing but R by Z. What is R? That is nothing but 60. What is Z? 100. Simple. Alpha by 10. What is alpha value? Alpha value is nothing but 6. Next question. See here, question number 35, matching of some theoretical answers. So, radio wave is due to rapid acceleration of electrons. Microwave is produced by the magneton value, and infrared wave due to the change in vibrational modes of the atom, and the X-ray due to inner shell electron moving from the higher level to lower level. So see here, this is option 1, option 2, option 3, option A. 4 is option A. So what is the correct answer? I hope. So option 4 is the right answer. So next question, see here. Good. A spring force of constant 15 Newton per meter is cut into two pieces. If the ratio of their length is 1:3, then the force constant of the smaller piece. What they are asking? Force constant of smaller piece. So see, this is our one spring having force constant K, that is nothing but 15 Newton per meter. Take this one K1. So which is cut into two pieces. So see here, 4L by 3 and L by 4. 3L by 4. Okay, you have to find the spring constant for a smaller one, L by 4. We know that one, Kx equal to constant. What is X? X is nothing but a elongation or compression, whatever it may be. So K1 L1 equal to K2 L2. What is L2? L by 4. What is L1? L only. K1 15. So see here, L, K2, L by 4. So K2 can be written as K into 4, that is nothing but 15 into 4. You can simply write 16 Newton per meter. So option 3 is the right answer. Question number 36. Next question, see. Question number 37. Potentiometer. Two resistors, 2 ohm and 3 ohm, are connected in the gaps of a bridge as shown in figure. The null point is obtained with the contact of a jockey at some point. So take this point is x. So total length is 100 centimeters. You can, if you mark this x, you are remaining with 100 minus x. When unknown resistor is connected to parallel with a 3 ohm resistor. So one unknown resistor is there and is connected to parallel with a 3 ohm. Take this R. The null position is shifted by 22.5 centimeters towards the Y. So we are having towards Y 22.5 centimeters. So we are having second position here. This is our second position. So x plus 22.5 centimeters and 100 minus x into x minus 22.5 centimeters. Then the resistance of unknown resistor. So see here, 2 by 6, case 1, 2 by 3, 2 by 3 can be written as x by 100 minus x. So from this one you can write x value can be written as 40 centimeters. For second case, 2 by, you have to include this extra R also, which is parallel to the 3 ohm. What is the equivalent resistance here? 3R by 3 plus R equal to, what is the value? Value of x. X is nothing but 40. So 40 plus 22.5 centimeters by 60 minus 22.5. If you solve this one, you will get R value as 2. So option 2 is the right answer. Next, question number 38. Statement 1 and statement 2. For all elements greater, the mass of nucleus greater is having binding energy per nucleon. So what they are saying, if the mass of nucleus is greater, then binding energy per nucleon is also greater. This is wrong. For what is the condition for a greater binding energy per nucleon? So 30 less than A, which is less than 170. This is our number. We are having greater binding energy per nucleon. So statement 2, this is false. For all elements, nuclei with less binding energy per nucleon transform to nuclei with a greater binding energy. What they are saying, if you are having nuclei of having less binding energy per nucleon, it is transforming into higher binding energy per nucleon. So this is also right answer. This right answer, because nucleus are wanting stability. They want stability. That's why statement 2 is the right answer. So statement 1 is false and statement 2 is true. Question number 39. A brass wire of length 2 meter and a radius 1 millimeter at 27 degrees is held taut between two rigid support. Initially, with it was cooled to a temperature of minus 43 degrees centigrade, creating a tension in wire T as the temperature which wire has to be cooled in order to increase the tension in 1 point T. So what they are asking, we are having one wire. It is in our rigid support at 27 degrees minus 43 degrees centigrade. We are having a tension -43 degrees. We are having tension T At what temperature tension can be 1.4 times of the initial tension? That is the query. You have to find the theta. So you have to find the theta, that is nothing but degree centigrade, how much temperature. So we know that one formula. What is the formula here? So for tension, we know that formula, tension T equal to YA alpha into change in temperature, that is nothing but change in temperature, that is delta T. See here, first case T, tension is T, and YA alpha 27 degrees minus 43 degrees centigrade, minus of minus plus 43. Okay, this is our first condition. Next, what is the tension? 1.4 times of the tension YA alpha into 27 minus, you have to find the theta. So this is our second equation. If you divide these two equations, you are cancelled with all the things. If you find theta value, you will get the value as minus 71 degree centigrade. Option 2 is the right answer. Okay. Next question. Question number 40. The electrostatic potential in a charged sphere, a region of radius r, as varies. They have given potential formula where A, B are constants. The total change in sphere of a unit radius. This is very, very important. The total charge. You have to find what is the charge of a sphere of unit radius. What is R here? Radius. Radius is nothing but 1. How to find total charge in sphere of a unit radius? So phi can be written as Q enclosed by epsilon naught. We want Q enclosed. Q enclosed by Q enclosed equal to phi into epsilon naught. You can write it as E dot A into epsilon naught. That is nothing but area of the ring. So area of the sphere. Sorry. So next one, see here how to find E. We know that formula. E equal to negative gradient of potential. We know this formula. So from this one, substitute the value of V. You will get 3AR square minus 3AR square. So substitute here minus 3AR square. What is R value? 1 square into what is A? 4 pi R square. 4 pi R square. 4 pi R square, that is 1. So multiply this one. So minus 12. Here you are having epsilon. A pi epsilon naught. This is our value of the alpha. What is the value? Minus 12 is the alpha value. So next question, see here. Question number 41. Two masses 400 G and 300 G are suspended from the ends of the light string passing over the heavy pulley of the radius 2 cm. When released from the rest, the heavier mass is observed to fall 81 cm in 9 seconds. The rotational inertia of the pulley is. Rotational inertia of the pulley is. So see here, we are having one pulley. One pulley of two masses M1 and M2. M2 is greater than M1. Take this condition. Tension 1 and tension 2. What is the condition for acceleration in this system? Acceleration in the system. Forget about this pulley. Acceleration can be written as m2 minus m1 into g by total mass. By total mass. What is the total mass here? m1, m2. So m1 plus m2 plus. If you are considering pulley, you have to take the mass of the pulley. What is the mass of the pulley? So from inertia formula, I equal to m r square, take this capital M or small m, whatever it may be, m r square. From this one you have to find m. So m can be written as I by r square. I by r square. This is a very simple condition to remember. Total mass. You are having total mass. So next one, see, you have to find the value of a value. Acceleration you have to find. You know this one, m2, m1 and m1, m2. I, you have to find I, and r is there. We are having r is equal to 2 centimeter. How to find? S equal to ut plus at, half at square, half at square. So u is 0. So that's why acceleration, how to find acceleration? Acceleration can be written as 2s by t square. 2s by t square. They have given displacement 2 into 81 into 10 to the power minus 2 by t. That is a t square, nothing but 81. 81 gets cancelled. A can be written as 0.02 meter per second square. So substitute in this equation and take this m2 and m1, and r can be written as 2 into 10 to the power minus 2. I am writing here, see, 0.02 equal to m2. That is nothing but 400 minus 350, that is 50 into g, that is 10. After this one, m1 plus m2, that is 750 plus I by r square. So we know this one, r square. Substitute this in equation. So you will get the I can be written as, if you simplify this equation, you will get I as 1.86 into 10 to the power minus 2. This is our actual method to solve this one. So just substitute the values and you will get the answer. So next one, see here, question number 42. Question number 42, see here. An unpolarized light is incident at an interface of two dielectric media having refractive indices 2 and 2√2 respectively. To satisfy this condition, that reflected and refracted rays are perpendicular to each other. What is this condition? Reflected and refracted rays are perpendicular to each other. That is nothing but Brewster's law. From Brewster's law, you can write tan theta can be written as this is our condition. One unpolarized light. This is our mu1, mu2. What is mu1? Mu1 is 2 and this is our mu2. This is our reflected and refracted rays are 90 degrees. This is the condition for Brewster's law. So mu2 by mu1 can be written as 2√3 by 2. That can be written as a √3. So tan 30 can be written as √3. So what is the angle here? 30. Next one, see here, 43, question number 43. A boy thrown a ball into air at an angle 45 degrees from the horizontal line. So this is from projectile motion, see here. So theta is 45 degrees. land of height h. If the ball is attains at a maximum height, so this is our maximum height at t equal to 2 seconds. This is our h max. Okay, and lands on the building in 3 seconds after launch, then value of h, then value of the height of the building h. V equal to u plus 80. In this condition, at a maximum height, velocity is 0. So 0, u, you have to find u minus acceleration due to gravity into t. What is u can be written as 10 into 2, that is nothing but 20 meter per second. This is our initial velocity. What do you have to find? You have to find the height. So height h can be written as ut plus a half at square. So what is the value of u? U can be written as 20. How much time? After 3 seconds, that is 3. What is acceleration due to gravity minus g? Half into 10 into 9. So 5, that is 60 minus 45, you will get 15 meters. So height is nothing but 15 meters. Option 4. Next question. Question number 44. There are 3 concentric conducting spheres, shell A, B and C of radii A, B, C respectively. The potential of spheres A and B respectively. So see here. 1. Okay. This is having radius A. This is B. This is C. Okay. Q1, Q2 and Q3. So potential at A, K Q1 by A plus K Q2 by B plus K Q3 by C respectively. So option 2 and 3 are same. Next one, VB. At this one, at this point, you have to consider radius B only. Don't consider A. So K Q1 by B plus K Q2 by B plus K Q3 by C. From this one, you can simply write K Q1 by Q1 plus Q2 by B. So for option potential C, you can write simply K equal K into Q1 plus Q2 plus Q3 by C. So option 3 is the right answer. Next one, see here. Question number 45. 3 masses 200 kg, 300 kg and 400 kg are placed at the vertices of equilateral triangle of having sides 20 meter. So take this one, M1, okay, M2 and M3 of having side 20 centimeters. They are rearranged on the vertices of bigger triangle of side 25 centimeters. So one more triangle, these masses are arranged in a bigger triangle of 25 centimeters, M1, M2 and M3. Center is same. With the same center, the work done in progress. What is the work done? By changing this small triangle of 20 meter side to 25 meter side. So what is the work done? Work done, simply you can write change in potential, change in potential, change in potential energy. We know that one potential energy is nothing but minus G m1 m2 by r. So how to find a change in potential? You can simply write minus u final plus u initial, or you can simply write u initial minus u final. What is the change here? Only change is side. So but masses are same. So see here, u initial can be written as, I am writing G outside and R outside, minus G by R. What is this R? 20 meter. G by R. M1 into M2. So I am writing here M into M2 plus M2 into M3 plus M3 into M1. M1 into M2. I am writing here, see here, M1 into M2. This is our 6 plus 12 plus 8 into 10 to the power 4. I am writing zeros here. So add these two, minus G by R. What is this one? 20 into 26, 10 to the power 4. So similarly, U final can be written as minus G, that is nothing but 6.7 into 10 to the power minus 11 by 25 into 26 into 10 to the power 4. Initial energy minus final energy. Okay, if you do the simplification, you will get the answer 3. Option 3 is your answer. See this one, section B, question number 46. What is the query? A short bar magnet placed with its axis at 30 degrees with an external field of 800 Gauss experience a torque of they have given torque and work done in moving from most stable to most unstable state. What is the query? Most stable state to most unstable state. So see here, we know that formula. What is the formula? Work done can be written as mu B minus of minus plus mu B can be written as 2 mu B. So we know that the torque formula, torque can be written as a torque equal to mu B sin theta. So this is a 0.016 mu into B. This is theta is nothing but 30 degrees, that is 1 by 2. If you multiply, see here, what they are asking, value of alpha. Okay, mu can be written as 0.0232 by B. This is our mu. So substitute here in this work done formula, 2 into 0.032 by B into B. If you multiply with 2, you will get a 0.064. What is the value? 10 to the power minus 3. You will get a 640 into 10 to the power minus 3. So this is our 640 is our answer. Next question, see here, 47. A gas of certain mass filled with a closed cylinder at a pressure of, they have given pressure in kilopascals. As the temperature is 50 degrees, the gas is now heated to double its temperature. So double its temperature, then what is the modified pressure? So we know that next one, final pressure can be written as 2 times of initial pressure, that is nothing but 2 into 3.23 kilopascals, that is nothing but kilopascals PA. So 6.46 into 10 cube, you can simply write 6460 pascals. This is our answer. So next question, see here, question number 48. A volt regulating circuit consists of a Zener diode having breakdown voltage 10 volts and maximum power dissipated. They have given power. The operation is at 15 volts. The approximate value of a protective resistance. So see here what they are asking. So we are having one Zener diode of having resistance 10 volts and one more voltage is there 15 volts and a resistance R. You have to find the value of R. So see here, we know that one maximum power dissipated can be written as 0.4 volts. This is nothing but I into V. So see here, I can be written as what is V, that is nothing but 10, I10. So I can be written as 0.04 amperes. So voltage is nothing but what you have to find? You have to find a resistance. Voltage can be written as 15 minus 10 by 0.04, that is nothing but 5 by 0.04. You can see this one 125. 125 is the your answer. Next question, see here, it will take little bit time. See here, question number 49. In the given figure, the blocks A, B, C and weight 6, 4, 6, 8 kgs respectively. The coefficient of sliding friction between any two surfaces, that is nothing but 0.5, that is half. The force F is required to slide the block C with a constant speed. Constant speed means F net can be 0. For A, block A, what do you have to take? N can be written as, I am writing here, M into Z. What is the mass here? 4 into 10. You can simply write 40 Newton. What is sliding friction? Mu into N. What is mu? Half into 40. You will get 20 Newton. What about block B? So at block B, we are having a weight through the block A and a normal force from the block B. So see here, N, take this N1, F1. So N2 can be written as M1 plus M2 into G, that is nothing but 6 into 4, that is 10 into 10, that is 100 Newton. 100 Newton. So F2 can be written as 50 Newton. At C, same, we are having 3 weights. So N3 can be written as M1 plus M2 plus M3. What is this one? 60, 180 into G, 10, 180 newtons. So friction can be written as 180 by 2, that is 90 newtons. These are the frictional forces between the blocks. F3, F2, okay, sorry, F3, F2, F1. What do you have to find? You have to find the force required to slide. So you have to find F. For block C, F can be written as, so there is a tension in this string T, and what are the forces? 90 Newton plus a tension plus a block A, that is 20. For block B, what you are having? So tension can be written as 20, so 20 Newton due to the block A and 50 Newton due to the block B, you are having 70 Newton. So substitute in this equation tension, what you are getting? This is not your 20, this is due to block B. What is the block B force? That is a 50. That is 50. So after that, what is the minimum force required to slide that block C? What is that force? So from here you have to write. So F can be written as 70, 50, 210 newtons. You are having 210 newtons to slide that block C. So last question, question number 50. Very important model as the aspect of JEE. See here, question number 50. 64 are raindrops of radius 1 millimeter, each falling down with a terminal velocity of 10 centimeter per second, coalesce to form a big drop, the terminal velocity of the big drop. So we know that terminal velocity formula 2r square g by eta into 9, rho solid minus rho liquid. So from this formula, terminal velocity is directly proportional to r square. Okay. What do you have to find? You have to find the r values of r. So we are having 64 small drops and these are forming a big drop of radius capital R or R2. This can be R1. So what is the R2? R2 can be written as n to the power 1 by 3 into R1. So 64 to the power 1 by 3 into R1. So from this one 4 R1. So see here, VT2 by VT1 can be written as R2 4R1 by R1. R1 gets cancelled, square. You have to take square. So 4 square, what will be the terminal velocity, final terminal velocity, that is 2T2. For first terminal velocity 10 centimeter per second, we are having 16. So 16 into 10 is nothing but 160 centimeter per second. That is our final answer. So this is our end of the session. So thanks for watching. If you are having any doubts, please comment below. Thanks for watching. Thank you.